All right, welcome back again. Now we are going to take our second example. Suppose that A and B are angles in a standard position with sine A given as 4 on 5 with this condition. That is A. A is the angle given here. A being less than pi, which is 180 degrees, and then greater than pi on 2, which is 90 degrees. And then cos B is given as negative 5 on 13 with this condition. That is angle B less than 3 pi on 2, which is 270 degrees, and greater than pi, which is 180 degrees. We have to find the value of sine A plus B. Good. Now, let's look at the first part of the question. Sine A is given as 4 on 5, and we know sine is opposite on hypotenuse. So we can easily do a right angle triangle, but a condition has been given here. That is the angle A is greater than pi, which is 180 degrees, and then, it's less than pi, which is 180 degrees, and greater than pi on 2, which is 90 degrees. So if you should draw the Cartesian plane, now you have pi on 2 here as the 90 degrees, pi, 3 pi on 2, which is 270, and then 2 pi, which is 360 degrees. Now there is a condition given. Angle A is less than 180 degrees. Here is where 180 degrees can be found. But greater than pi on 2, which is 90 degrees. So angle A is greater than 90 degrees, but it is less than 180 degrees. It's not up to 180 degrees. This means that angle A falls in the second quadrant. Now in this case, we can draw a right angle triangle here. So the angle A falls here. Now, sine A is opposite on hypotenuse, so we know where angle theta faces is the opposite, which is 4. And then where angle 90 degrees faces, that's the longest side of the hypotenuse. The longest side of the right angle triangle is a hypotenuse. So we have 5 here. So clearly we can find this side, that's the adjacent, by using the Pythagoras theorem, which says that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So let me say, I'll name here x, since we don't know the value of this side. So 5 squared will be equal to the sum of the squares of these two sides, which is 4 squared plus x squared. Now we have 25 minus 16, which is equal to x squared. So clearly 25 minus 16 is 9. So we have 9 is equal to x squared. This implies that x is equal to 3. But we should note that the value here, we know that this side is the negative side on the y-axis. This is the y-axis, and then the value that we had here is 3. So if I should write here 3, it becomes negative because it has fallen on the negative side of the y-axis. So in this case, x is equal to negative 3, not 3. Very good. We are done with this. So now we go to the second part of the question, which is cos B is equal to negative 5 on 13. So if I should have another Cartesian plane here. Now cos B is neg 5 on 13. Now where do we find angle B? Is it going to be in the first, second, third, or fourth quadrant? Now the condition is that the angle B is is less than 3 pi on 2. And there is 3 pi on 2 is here, which is 270 degrees, but greater than 180. It's greater than 180, but less than 270. So angle B falls in the third quadrant. Now, for cos, we know that cos is given as the adjacent on hypotenuse. So now where angle theta faces the opposite, and where angle 90 degrees faces is the hypotenuse. So in this case, we have 13 here. And then the adjacent, the opposite here, hypotenuse, so adjacent here as negative 5. So we can easily find this side using the Pythagoras theorem. That is the hypotenuse squared, that is 13 squared, is equal to the sum of the squares of these two sides. So let's say here is y. So we have negative 5 squared plus y squared. And we know 13 squared is 169, which is equal to neg 5 squared, 25 plus y squared. So we have 169 minus 25, which is equal to y squared. 169 minus 25, we have 144, which is equal to y squared. This implies that y is equal to the square root of 144, which is 12. But we should know that this side, or the value of y, falls on the negative side of the y-axis, it implies that the value of y is negative 12 and not positive 12. So y will be equal to negative 12. We are to find the value of sine A plus B. We are to find the value of sine A plus B. So clearly we are going to use the compound angle for sine A plus B, which we know is equal to, is given as sine A cos B plus sine B cos A. That means we have to find these parameters, sine A cos B. We have to find the value of sine B and cos A. Good. Now what's the value of sine A? Sine A was given in the question as sine A was 4 on 5. And then cos B was also given as negative 5 on 13. That means we have to find sine B and cos A. How do we find sine B? Now we can find sine B from here. Since we know sine is opposite on hypotenuse. So from here, there is our opposite. Hypotenuse being 13. Likewise, we can also find cos A from here. Because the angle here is A, so we have to find cos A from here. So cos A, as we know, is adjacent on hypotenuse. So where is the adjacent? So opposite hypotenuse, the adjacent is negative 3 on the hypotenuse, which is 5. So we just do the substitution from here. Now sine A plus B is equal to the whole of this. What's the value of sine A? Sine A is 4 on 5. Cos B is negative 5 on 13. Plus sine B, which is negative 12 on 13, multiplied by cos A, which is negative 3 on 5. Now if you point all of this on calculator, you are going to get 6 on 65. Thank you.